Hello, my name is Louie, and this is my Physics Lab 5. First, let's go over some models and principles. Our lab will be looking at collisions. We'll examine conservation of momentum, and we'll be using Newton's first and second laws, mostly focusing on the momentum principle. We'll to complete this model, we'll be using Tracker Online, which we'll use to track motion of two erasers colliding, which will yield numerical data that I can do math with. And I will use these tools to track and create data for real-world collision for analysis. And I will only be doing an experiment. I will not be doing any coding, as you can see in the canvas. So here are two graphs that I got from my experiment. This is directly from Tracker. You can see the first object has negative velocity as it's moving to the left, which you'll see in the video that I'll show in a second. And the second object has no velocity, and once they collide, the first object has less negative velocity, and the second object has a lot of negative velocity. So let me show the video. Alright, now let's go over some physics equations and ideas. Firstly, in collisions, the change in total momentum is zero. So we will look at the momentum of the first object and the momentum of the second object initially, and that should be equal to the momentum of the first object and the second object final. We'll be using the momentum principle right there, and so the change in momentum is zero, derived from Newton's second law. Momentum is a vector. Must look at each component, both initial and final. What? If change in kinetic energy is zero, collision is elastic, if not inelastic. And we'll be assuming no motion in the z direction, obviously. Here are some images from a spreadsheet that I made of the data so I can better view my collision. So you can see the two graphs of position as well as velocity that I made just using the instantaneous velocity given the position and time. And then here's the total spreadsheet. And as you can see here, this is where the velocity becomes zero. And that's where the two erasers are stopped because of friction. Here are the calculations I did. You can look at the initial velocity. You can see that I only used velocity in the x direction, as that's where the majority of the momentum was in the x direction. Then I set them equal to each other. And as you can see, I did not get an equal number, and we'll talk about that. Also, they weighed 41.9 grams, if you're so curious. So why is this figure incorrect? Firstly, the natural velocity loss could be due to friction, sound or internal vibration, or small variations in the velocity because of the y-axis. Or it could be user error on my part, which a math mistake? I don't think so, but you can take a look if you want. Please still give me 100 though. An error plugging my data into the spreadsheet, or a problem with Tracker Online, or some kind of distortion from the camera lens on the whiteboard, but I doubt it. I think it's probably mostly from friction. Comparison analysis and limitation. Our experiment unsuccessfully modeled collisions because the initial was not equal to the final momentum. Limited by user error and natural loss of energy to the environment. In the future, I would want to track y-axis as well to make a more accurate experiment. And here is a graph of our data. I don't really know what's going on with the velocity graph. I think that's where the collision is. I don't really know why it goes back up that much. If you figure it out, drop it in the comment section below. So here's some extension questions. What if I was better at physics? Then I would have analyzed the anti-Kythera mechanism. A winky face emoji if you know what's up. What would it mean if I included y velocity in my analysis? I likely would have gotten a more accurate outcome for my momentum final figure, although it would have made my calculations and graphing much more complex. Thank you guys for watching my video, and I hope you have a wonderful day, and I think you guys should give me 100 because I tried really hard. Thank you. If you made it this far in the video, leave a comment, like, and subscribe. If you do, I'll tell the professor to give you an A in the class. Thank you for watching. Ding!